Alright, so we're going to work through some examples of graphing polar equations. We're going to look at a little bit of a review of some of the pre-cal stuff. On the BC exam, when these show up, it's really important that we can create the graphs quickly without doing a point-by-point graph. If we have to do a point-by-point graph, it's going to take us too long. It's going to eat up too much of our time. So it's really important that we can make quick and accurate graphs of certain types of polar graphs. So the first one, the first two really are special cases. When we have r equals a constant, we're going to get a circle, and it's going to be radius r centered at the origin. So if we have r equals 2, we're going to have a circle with radius of 2. Pretty straightforward. If we have theta equals a constant, then we're going to get a graph along the theta line. So if we think about this one, again, we have some polar graph paper here. 3 pi over 4 puts us here. All right. So the line that we get is going to continue this way and right down here. So we're going to get this part of the line when we have a positive r. We're going to get this when r is equal to 0, that point there at the origin. And we're going to get this side of the line over here when r is negative. All right. Another form that we'll see quite often is when r equals a sine theta or a cosine theta. And these are going to be circles with their centers on the x or y axis. So here I have an example of r equals 2 sine theta. This circle is going to have y-axis symmetry. And one way to remember that is that the sine of theta equals y over r. So that kind of gives me that reminder that my center is going to be located on the y-axis. Since the coefficient is positive, I'm going to be above the x-axis, so I'm going to be up here. So again, if we have polar graph paper, it's going to look like that. So here the diameter of my circle is 2. So I'm going to get a circle that looks like that, with a diameter of 2 located on the y-axis. In this case, again, because of that positive 2, I'm going to be above the x-axis. So we want to think about what angular measurements are giving us this circle. We start right here when theta is 0. We're out at r equals 2 when theta is equal to pi over 2. And then we're back to 0 when theta is equal to pi. So you can see that we get that entire circle for theta from 0 to pi. Right? We don't have to go 2 pi to get an entire circle. We go from 0 to pi and we get one circle. If we went from 0 to 2 pi, we would get this circle 2 times. Now if we look at r equals negative 3 cosine theta, we have x-axis symmetry here. So we're located on the x-axis, and again we can get a reminder of that if we think about the fact that cosine theta equals x over r. So we're on the x-axis. Because of this negative 3, we're going to be to the left of the origin. So we're going to have a diameter, 1, 2, 3. And we're going to get a circle that has a diameter of 3. So again, let's think about the the measurements of theta that are going to give us this circle, we're going to start at 3 over here when theta is equal to 0. Alright, so think about it this way. If theta is equal to 0, we're kind of standing in the center, pointing in the direction of the pencil point. But and so at that case, cosine of theta is equal to 1. But r is equal to negative cosine, negative 3 cosine of theta. So negative 3 times 1 puts us backwards 3. So this is theta equals 0. We're back here when our angular measurement is theta over 2. So when we're here, cosine is 0, so we're at the origin. And then when we're at theta equals pi, we're going to be back at this point here on the left with our radius equal to 3.